Hi everyone, I'm Florent. I'm a developer. I like tools and a lot of different things like that, and C++. And I'm going to do a short note about safety, intentionally vague, but you will see what it is about very soon. A bit more about me so you get my background. I've been through a few different companies here. Spotify, where I did develop a tool, C++ and all that. Same thing at Google, and I worked on bigger projects like WebRTC and Chromium. And now I'm working at a company called Angeflow, where I'm doing some build acceleration to make sure that you can do remote executions of all your builds, whether CMake or Bazel. And so I have a problem. I want to write some code that is generating some words, saving them, and I want to do it very fast. So what do? Well, obviously I'm going to use threads. That's the easy solution. And so I have a class writer here with a function write, adds a word to a vector, and a function threaded work that is called for many threads. And that function is going to add many words that are very hard to compute. Well, stud format in this case, but you can imagine something much more complex, and adding that to the one writer object. And I'm like, this must be real fast. I'm really proud of this code. And then I run it. Abort. It crashes. Oh no, what happened? So I'm like, what's going on? I'm like, well, I'm using threads, so the logical solution to that is to use thread sanitizer. So I run it and I get this, and 10 more screens of this. So I'm like, I don't understand. What do I do? So I got an error from thread sanitizer, and I just give it to some random AI tool that I found on the web, and it tells me, what does it mean? It means that you have a vector of strings, probably, because I just gave it the error, I didn't give it the full code. It was smart enough. And you're writing to it from multiple threads without using a mutex or the synchronization mechanism. And it tells me that pushback is not thread safe. I cannot call pushback from multiple threads on the same instance without synchronization. Well, it's kind of obvious. What do? I add a mutex, right? My mutex is good. It still doesn't work. Oh, well, yeah, I forgot. I need to add a lock. I add a lock. I say, before I push back, I need to hold the lock. Only one thread can access this at the same time. And then, success, it works. Hooray. But maybe I'm wondering, the compiler is a smart entity. There's a lot of smart code in there. Why couldn't it help me find that kind of error in the first place? Because it knows about variable access, order, and a lot of things like that. And maybe it should be able to help me there. And that's where I would like to introduce a very old tech, well, very old, relatively, in current terms, but it's been around for a while, called the Clang Thread Safety Analysis, Clang TSA, as some people call it. And it's using thread safety annotations, TSA also, it's a bit confusing, to verify your code at compile time. It's not TSAN, it's something that is running at compile time. So if you get this version of the code, which is incorrect because I don't use a lock, how do I make it work? Well, it's kind of simple, actually. I just tell it, hey, I include some header that has a lot of preprocessor defines, that defines all the annotations. And then I annotate my words here, and I say my words member is guarded by a mutex. So now the compiler knows that anytime I want to access words, I should hold the mutex. And if I don't, I want it to scream at me. So I can try that with that code. If I compile it with a few extra options, I'll get to talk more about them. It tells me, hey, you're reading a variable word but it requires holding a mutex called mutex. And that's a warning from the thread safety analysis. Hooray, the compiler is helping me. The compiler is my friend. That's really nice. And so if you want to enable the analysis, it's relatively simple. Depending on the platform where you're using, just tell the compiler, Clang, it's not implemented anywhere else, that you want that warning. So you pass the flag, wthread safety, and then you need to have your compiler understand what is a mutex, what is the resource that you're trying to acquire. And so you need some annotations in your standard library. Fortunately, there are some good libraries that come with those annotations. So if you're using libc++, which is the standard library that comes with Clang on a few different platforms, then you have access to those. So if you're on Linux, you need to tell Clang explicitly to use libc++. If you're on Mac, iOS, Android, it's already used by default, so you're good. On Windows, well, you need to compile it yourself because it doesn't ship with the LLVM distribution. That's a little bit unfortunate, but it's possible to do. I've done it. And then you tell the preprocessor to enable the thread safety annotations, which is something that is documented in libcpp to enable some features. There's a few features you can enable and disable in your standard libraries, and that is one of them. If you're using Boost, it's easy. Just pass one define, and all your Boost mutex and other type of mutex will be annotated. So that's really convenient. But what else can it do? Well, the annotation can do a few more things. For example, imagine you want to write a lot of words that you generated in batch, and you don't want to use the write function that is blocking the mutex every time. So maybe you could hold the mutex externally and then write without checking the mutex. So you can do that. For example, you add another annotation, and you say, if I want to call this write uncheck function, I need to it requires the mutex to be held. And you can do a lot of different things like that. And then the compiler will scream at you and remind you, hey, you don't have the mutex held when you're using this function because you told me you should. If you have your own custom mutex, maybe it happens, or other resource that you need to acquire, because it could be, I don't know, a file that you need to hold a lock on or something like that, well, you can annotate your own classes. You can tell, hey, I have a class mutex. It's a capability type of mutex. It's a magic word that the analysis pass understands. And then you say, hey, I have this function that is called lock, uppercase, that acquires the lock, this lock, and unlock that releases it. That's relatively simple, and you can expand on that. You have more annotations that you can use. So I showed you one called guarded by that says, hey, this member object is held protected by this mutex, but you can say the pointer, this pointer here, the thing pointed to, is protected by the mutex, and not the pointer itself. You could have also annotations on functions that say, hey, this one is a function that is acquiring the resources, releasing the resource. You can have annotations that work with shared mutex. If you have a reader-writer mutex, you can have multiple readers that are all acquiring a shared mutex. They can all read from the variable. They're not going to modify it. But when someone wants to write, they need to acquire an exclusive mutex. And that is supported, and the annotations understand that. And you have a few different mores that tell you a lot of different things. There's a lot of documentations about all those. So yeah, but why would you use that? Well, I think compile time detection is a lot better than having it fail after a long build and running tests for a long time in a long pipeline in CI. I'd rather things fail early in compilation time. And usually your developers will see that, because if you enable that on your debug builds, people will see it. So it catches the data erased before your code is run. It's a lot cheaper and a lot easier to understand than something like thread sanitizer errors, where I had to use an AI tool to tell me exactly in plain English what was happening. With some experience, you can understand them, but if you haven't spent a lot of time reading those, it's very daunting, especially with all the templates that are in the standard library. It improves the code clarity as well, because annotations are documentation, and it's a contract that you have not only with the compilers, but with the other developers on the project. And you tell them, hey, when you want to use this variable, you need to get this mutex, you need to do this. If you call this function, you need to make sure that you don't have this mutex held, because it's going to be later being held by one of the functions that it calls. So you need to, you can do a lot of things with that. You can add preconditions, postconditions, and all that. And I think it's good practice. If you annotate all of that, you will have safer code. But is it perfect? No, it's not perfect. Otherwise, everyone would already be using it. But it's not a replacement for runtime tools. If you have some complex patterns in your code, the analysis pass will not understand what it's doing. Do you have some branches that will conditionally lock or not your mutex? Then the analysis will say, hey, that doesn't work, and you need to say, hey, don't analyze this function. Trust me, I'm doing the right thing. It's not perfect. It's not going to catch everything. But is it going to catch a lot of easy errors? Probably. And maybe that's good enough for you to use. Requires people to, well, use it. You need to annotate your code. If you don't annotate your code, your warnings are never going to be thrown at you. So requires a little bit of structure. And it can be verbose. If you have very complex code, the annotation can be very complex. But hopefully you don't have very complex code everywhere, so you might have just a few experts in your application domain that is handling that for the other developers. So if you want to know more about this, you search for Clang thread safety analysis on your favorite search engine, and you will get this link. You have a lot of examples about how to use all the annotations. You have a lot of talks that have been made about it. This talk has been made in 2011 at an LLVM conference. So the technology has been there for a while, but is it used widely? Well, I don't think so. If I search Chromium, the technology is backed by Google, so it's used widely inside of Google. And it's used quite a lot in the code base, but not a lot of code requires explicit synchronization, so it's not necessarily used thousands of times, but yeah, it's still used many hundreds of times. If I search GitHub for guarded by, specifically for this, and skipping all the defines and processors, preprocessors defines that say how it works, I get almost 94,000 files that are using it multiple places. There's certainly duplicates and all that, but it's a rough number. So I'd like to know how many occurrences are there of guarded by in your code. Are you leveraging all the tools that you can to make your code safer? Think about it. Thank you.